Good day, everybody. We've been given this question, square root of 15 negative 4 times root of 11. We are expected to simplify this expression. You can pause the video and attempt this question and find out if your answer agrees with the answer that is being explained here. Okay, so having mentioned that, the idea is without the calculator's introduction or without the use of calculators, the only way that we can simplify this is to convert this into a perfect square. That's the key. So what I wish to do is I would like to consider 15 negative 4 times root of 11. Then the quantity inside the square root, which is called as the radicand. Now that is the key. Now what we got to do is we will have to express this quantity 15 as some times, or I would say as a component which has this radicand featuring as one of the additives or one of the terms that are being added. So in this case, I will have to write 15 as some x added with this radicand 11. So in this case, 15 can be rewritten as 4 positive 11. So that's the best representation we have, which involves 11. So having mentioned you that, let's move on. So I'm going to write 15 as 4 positive 11. That's the first term, followed by, I'm going to write 4 times root of 11. Is it okay if I can write 4 times root of 11 as 2 times 2 times root of 11? So clearly I can write 4 times root of 11 as 2 times 2 into root 11. So clearly you can see that we are slowly but steadily actually converting this term into a perfect square. So if I were to have the first term 2 and the second term as root of 11, upon squaring 2, I would get 4. Upon squaring 11, I would get 11. 4 added with root, 4 added with 11 would give me 15. So the first term is already obtained. Now comes the middle term, because if I were to place a square here, the square of the first term and the square of the last term already they add up to give me the first term. But I need to cater to the 4 times root 11. So for that 4 times root 11, all I need to place here is a negative sign. So if you were to expand this is going to be 2 squared, negative 2 times of root 11, positive root of 11 raised to the power of 2. So this is going to be 4. This is going to be 4 times root 11. And this is going to be 11. So 4 added with 11 will give me 15. And clearly I got 4 times root 11. So clearly you can see that the perfect square is already achieved. So I hope you got that hint. Now there is one more thing you need to do here. So therefore I can rewrite root of 15 negative 4 times root 11 as square root of 2 negative root of 11 whole squared. Now you might be tempted to apply the square root immediately, but don't do that. What you got to do is you will have to make sure that this term root 11 is the leading term instead of 2 being the leading term. So for that to happen, what we got to do is we will, inside the square, we will have to take the negative sign. So if I were to take the negative sign out, this is going to be root of 11. So negative into root 11 gives me negative root 11, followed by, I need to get a positive sign here. So that's going to be negative 2 there. So all this is done inside the square. So I'm not involving the square at all. So inside the square, I am rearranging the terms, right? Now you know that if you have something like this, root of ab raised to the power of 2, you can very well write this as root of a squared times root of b squared. That's exactly what I'm going to do. Now this is actually a negative 1. So let me write that down. Negative 1 multiplied with root of 11 negative 2, and this entire component is raised to the power of 2. So this is going to be rewritten as negative 1 raised to the power of 2 times root of 11 negative 2 raised to the power of 2. Now this is going to be root of negative 1 square times root of 11 negative 2. Of course, this is square root of, and inside the square root you got root of 11 negative 2 raised to the power of 2. This is how it looks. Now, first you square this. Negative 1 raised to the power of 2 would give you positive 1. So that's going to be root of 1 there. Multiplied with root of, now I'm rewriting this, it's a little bit redundant. You don't have to do that. You can simply apply the square root function. So it's going to be root of 11 negative 2 raised to the power of 2. If you were to apply the square root function, now we can apply all through. So this is going to give me root of 1, that's going to be positive 1, root of this entire quantity. The radical sign and the square gets cancelled, giving me root of 11 negative 2, which is rewritten as root of 11 negative 2. Now you might be wondering why I did not include negative value, right? So because usually people say whenever you take square root of say 36, you get plus 6 and minus 6. No, but you don't get minus 6, you only get plus 6, because square root is a single valued function. Have that in mind. Many of the explanation, they would immediately justify, what if x squared is equal to 36? Okay, x squared is equal to 36, it means x squared negative 36 is equal to 0. It means x minus 6 and x plus 6 is equal to 0. Which means, in this case, x is equal to negative 6 is one of the values of x which solves the system. So in this case, we are solving for the variable. But in this case, we are applying the square root function. So a lot of difference are there between these two. And that's why I manipulated this in such a way that the outcome is acceptable. So in this case, the root of 11 minus 2. So I think this is a good place for us to stop. If you have any questions regarding the way that I had simplified this, please place them in the comment section. Thank you everybody. Enjoy your night.